In our previous class, we discussed about the physical and chemical properties of metal. Now we are going to discuss about the reactivity series of metal. In our previous class, we studied a type of chemical reaction, displacement reaction. In displacement reaction, a more reactive metal can replace a less reactive metal in its sulfate solution. We already studied that. For example, Fe plus CuSO4 gives FeSO4 plus Cu. When we put iron in copper sulfate solution, we get iron sulfate solution and copper. From this example, you can clearly understand Fe is replaced Cu in CuSO4. But if we try to do the same in opposite cases, what happened? When we put copper in FeSO4 solution, what happened? Nothing happened. Because iron is more reactive than copper. So iron can displace copper from its solution. But copper is less reactive than iron, so it can't replace iron from iron sulfate solution. Similarly, we can see many other metals. Some metals can replace some other metals. For example, if we put copper in silver sulfate solution, AgSO4 solution, we get CuSO4 plus Ag. But if we try to do the same in opposite direction, that means Ag plus CuSO4, we can see any change. Because copper is more reactive than silver. That means we already tell that a more reactive metal displaces a less reactive metal from its salt solution. But a less reactive metal can't do the same. By observing the above reactions, we can understand some metals are more reactive and some metals are less reactive. The arrangement of metals in the decreasing order of their activity is known as activity or reactivity series or electrochemical series. We can see a portion of electrochemical series in our text. First metal is potassium. It is more reactive metal than sodium. We know sodium and potassium, when we put in air or water, it reacts with air and water. Calcium, magnesium, aluminum, etc. In decreasing reactivity, Ag, Au, that means silver and gold are least reactive metals. This arrangement from potassium to gold is known as activity series or reactivity series. The most reactive metal is potassium, that represented by K, and the least reactive metal is gold, it is represented by Au. This series is known as activity series or electrochemical series. Then what is the source of metal and how do we obtain them? From where we get the metals? Metals are very important in our everyday life. We can't live without metal, so we want to know from where we get this. All the materials we need to live, we get from the earth crust. Earth crust contains all the minerals, all the materials that we want to live. We get some metals from our earth crust and some of them from water, sea water. The constituents of earth crust which contain these metals or their compounds are known as minerals. The constituents of earth crust which contains these metals or their compounds are known as minerals. At some places, mineral contains a high percentage of a particular metal and the metal can be profitably extracted from it. Such minerals are called ores. For example, seawater is an ore. We can simply extract sodium metal from seawater. Similarly, you may hear about the KGF, Kolar Gold Field in Karnataka. It's a gold mine. We get gold from there. There are a lot of places in the world, in the earth's crust, in different parts of the world. We get some special metal from there. That is known as ores. Ores means some places minerals contain a high percentage of a particular metal and we can profitably extract it from it. In our place also, our soil contains a large amount of iron, but we can't extract it from our iron because it's a less amount compared to ore. Ores means a special area contains a large amount of a special metal and we can profitably extract it from there. An ore taken from earth contains many impurities and it may be in the form of compounds of metals, oxide, sulfide or many other compounds. We want to extract metal from this. This technology is known as metallurgy. Getting pure compound of a metal from its ore and finally getting the metal from its pure compound is called metallurgy. Metallurgy means extracting pure metal from the ore. Ore is a metal. Ore contains a high amount of metal, but it contains many other impurities. This metal also may be in the form of many other compounds. We want to extract the metal from that. That is known as metallurgy. Getting pure compound of a metal from its ore and finally getting the metal from it pure compound is called metallurgy. Several steps involved in the extraction of metals from their ore. We can just go through them. We can classify metals into three categories: metals of high reactivity, metals of medium reactivity, metals of low reactivity. We get ore. Then we remove the main impurities just like mud, stone, etc. from that. Then we get the concentration of ore. Suppose seawater is our ore. We take seawater and evaporate water. We get the concentration of ore. That means sodium chloride. From that we separate the sodium. If you want to separate metals of high reactivity like sodium, potassium, the method is electrolysis. We can detailedly discuss each and every process in the coming section. We get pure metal. Then just electrolysis, we get the pure metal. If we get the metals of medium, we want to separate metals of medium reactivity. There are two steps. If we get the ore as in carbonate form, carbonate ore, we want to do the process calcination. If we get the ore as sulfide form, we want to it roasting. Then we get oxides of metal, then reduce it to metal. Again we take it as and purify it. Metals of low reactivity, most metals in low reactivity we get in pure form like gold. Maybe in sulfide ores we want to roasting it, then we get metal and we refining the metal. Then we can discuss detailedly each and every process. Metals in the lower part of the activity series are very unreactive. For example, mercury. We get mercury in the form of mercuric sulfide, HGS. It is known as cinnabar. The ore of mercury is known as cinnabar, HGS. we can extract easily. We take HGS in a container and heat it in the presence of oxygen, in the presence of air, in an open container. We get HGO, hydrogen oxide, mercuric oxide plus sulfur dioxide. Sulfur dioxide is gas. Then again heat, we get Hg. That means metals in the low reactivity part, we can separate metal only by heating. We get HGS, by heating we get Hg. Hg means mercury. Silver, gold, etc. are least reactive and found in native state. That means in pure form. Sometimes it may be in the combined state. Then metals in the middle of the activity series like iron, zinc, lead, etc. are moderately reactive. We get in two forms, in sulfide ores and in carbonate ores. For example, we take zinc. We get zinc in two forms, zinc sulfide and zinc carbonate. Then we want to separate zinc from this. We already studied two processes, roasting and calcination. Roasting means heating in the presence of air. That means heating in an open container. Calcination means heating in the absence of air, in the absence of oxygen. That means heating in a closed container. For example, we take ZNS, zinc sulfide, in a container and heat it without close its lid. That means in open air. We get example ZNS plus O2. 3O2 gives 2ZNO plus 2SO2. SO2 is sulfur dioxide gas. Then we get zinc oxide ZNO. We get zinc in the form of carbonate ore. We do the calcination. That means we heat in the absence of air. ZnCO3, zinc carbonate. Heat, we get ZNO plus CO2. Carbon dioxide is gas. Then we get ZNO, zinc oxide. In roasting and calcination, in both process, we get oxides of metal, zinc oxide. Then metal oxides are reduced by using another one, carbon, ZNO plus C. We get Zn, zinc plus carbon monoxide. We already studied about the oxidation and reduction process. We reduce oxygen from zinc by using carbon. We get a we reduce zinc oxygen from zinc oxide by using carbon. We get zinc and carbon monoxide. We get the pure metal. We can do another reaction for reducing metal from its oxide. For example, displacement reaction, Fe2O3, iron oxide plus 2Al gives 2Fe plus Al2O3. This is also another process of reduction reaction. In the case of zinc oxide, we add carbon, we get zinc. Similarly, in the case of Fe2O3, iron oxide, we add aluminium to it. It's a displacement reaction. We get aluminium oxide plus iron. This type of reaction is known as thermite process and is very useful in welding of rail tracks or other heavy machineries, because this reaction produces a large amount of heat, and the iron we get in a liquid form we use to welding in railway track or other machinery parts. Metals of the top of reactivity is seen as highly reactive. We use electrolysis process, that means passing electricity through the molten ore. For example, sodium chloride, that means the salt we used in our daily life. We take salt from seawater and make it a molten state. Then we pass electricity through them. We get Na plus one electron gives sodium and chlorine in cathode and anode. I think we already studied the electrolysis process. In electrolysis process, there is a one anode and one cathode. When we pass electricity through them, we get positive charged ion at cathode and negative charged ion at anode. Here sodium and chlorine. So we can extract any metal in least reactivity, most reactive and moderate reactive by through this process.